Welcome to the ET322 Transistor Driver Lab. Okay, so what we're going to do is we're going to calculate our collector resistor value. Okay, and we're going to use Ohm's law and some information. So we're going to have RC equals VCC, which would be 15 volts. Minus, we'll say 1.4 volts for our diode. And we want our diode to light at 20 milliamps, so we're going to divide it by 20 milliamps. And let's break out our calculator here, and we have 15 minus 1.4 equals divided by 20, second EE minus 3. And I have 680 ohms. Okay, we're going to design and size the base resistor. So first thing we need to do is know the beta of the transistor. 3904 is about 100. We'll use 100 and we'll double check that later. So down here we have IB equals 20 milliamps divided by beta. Okay, so what we want to do is, so we have 20 milliamps divided by 100. Second EE minus 3 divided by 100 is 200 micro. And we're going to multiply it by 2. So we're going to end up with 400 microamps. Okay, so now we're going to find RB. So we need VCC, which is 15 minus 0.7, and we're going to divide it by 400 microamps. And we should get 14.3 divided by 400, second EE minus 6. And I've got 35.75, and we'll probably use a 36. Good. Turn it off. Okay, we're going to use a current probe. Let's see how much current we have on our 18.7. That's close. And let's check our base current. And we got 400 microamps, just like we calculated. We're a little bit off here, but that may be that our LED is a little different on current. Yeah, so that's good. And close this out, and let's fire it up, and we should be flashing, and that's probably more than 10 a second, but it is flashing, and we have a flashing circuit. Top, and let's see if we can get it to work. What we're trying to do with this circuit is build a voltage current chart for our transistor. So first thing we want to do is figure out the voltage to emitter voltage. So we need another collector to emitter. Okay, and we want to set this guy at 0. And our transistor should be fully off, which means that we should get the maximum voltage on here. So let's make sure that we have everything set up, and we do not. Okay. Good. So let's turn it on, and we should get our 15 volts. Good. 15 nanoamps, that's almost zero. So what we calculated here is our collector to emitter voltage on our transistor. Good. Now let's go up until we get maximum current and 0 voltage. So let's start move up. And we should be getting eventually 5 milliamps and almost no voltage. So let's check a look at our circuit here. We've got 1K, 1K, 15 volts. So our current through this should be about 7. Okay, so that's going to be our collector current. Okay, from our IC and our VCE max, we're going to plot our load line. Now what we're going to do is we're going to try to find the midpoint where this thing is biased properly. So let's go ahead and okay, let's keep going down. Let's see here. Let's try to get 7 volts on that dude. There we go. Okay, so now we found our midpoint. We have 7 volts on our VCE and 4 milliamps. So that should plot out on our chart, and this is where we want this to be biased in order for it to become an amplifier. So we're going to put some AC on here and put capacitors in order to get this to be a amplifier transistor.